Okay, so for our last example today, we're going to prove the perpendicular bisector theorem, which says that any point on a perpendicular bisector of a segment is equidistant from the endpoints of the segment. So if we want a segment and a perpendicular bisector, it makes sense to put the segment right on the x-axis. There we go. So if I call this point A and this point B, and then we can say the y-axis is the perpendicular bisector. By the nature of the axes, the x-axis is always perpendicular to the y-axis, so that gives us the right angle that we need. And to make sure that it's a bisector, we want to make sure this distance and this distance are the same. So when we name this point, for example, if I name this point 2A, 0, then what should we name point A? So that it's the same distance away from the origin. Spencer? There you go. Good. Negative 2A, 0. So if it's 2A in one direction and negative 2A in the other direction, then that makes both of those lengths the same, which is what we want as our given. We want to be given a perpendicular bisector, and then we want to show that, or actually they named these point in the description of the problem, it says we're calling those points C and D instead of A and B. So our perpendicular bisector is A, B, which is our our y-axis. Okay, so we want to show that if we pick any point on AB, then it's going to be equidistant from C and D. Okay, so pick any point here. I'm going to name that point, I'll just call it point F. Okay, so point F is any random point on the y-axis. We want to prove that FD, this length, has to be the same as this length FC. So we're basically proving the perpendicular bisector theorem. Okay, so to guarantee that F is just any random point on the y-axis, what would you suggest for the coordinates? Which coordinate do we know for sure has to be fixed? X has to be 0 for any point that's on the y-axis. Okay, now we can name the y-coordinate anything we want, so let's make it a double value. And so we already used the letter A, so this time we'll call this 2B. So depending on what B is, B could be literally anywhere on the y-axis. Okay, and now we can use the distance formula to find those two values. So FD is going to be the square root of the x coordinates squared, the difference in the x coordinates squared, and the difference in the y coordinates squared, and then we'll try to simplify that. And then FC, we're going to do the same thing. We're going to use the distance formula. Difference in the x's, difference in the y's squared, and then simplify that. Okay, go ahead and try both of those in your groups. See if you can use the coordinates that are given to show that those have to have the same length. Okay, let's see how you did. So we're looking for the difference in the x coordinates for FD. So there's an x coordinate of 0. There's an x coordinate of 2a. And then for the y coordinates, 2b minus 0. If you did those in opposite order, it doesn't matter because we're squaring them. So we get the square root of 4a squared when I square that first one, and then 4b squared. And we can factor out a 4 and take the square root and get 2 times the square root of a squared plus b squared. So you can write it either way. That's correct, but this is simplified. Okay, now notice that it would not be correct to say that that is, to say that the square root of a squared plus b squared is a plus b. That is definitely not true. The square root of a squared plus b squared is only equal to a plus b if one of either a or b is 0. Okay, so don't make that mistake. So we'll just stop with either one of those two, and then we'll do the same thing for FC. So FC is negative 2a minus 0 when we're doing the difference in the x coordinates. So there's negative 2a and 0. And then for the y coordinates, 0 minus 2b. And then when we square those expressions, we get, again, 4a squared plus 4b squared. So already we see that these are the same. And if you simplify it, you're still going to get the same thing. So either way, we get that the lengths are the same. Therefore, FD is equal to FC, meaning F is equidistant from points C and D. Okay, which is what we set out to prove. Okay, so we used the distance formula to show that those two distances are the same.